Yesterday I spent a lot of time working one-on-one with people on balancing equations. It was really helpful for me to be able to work with them. What you as a class did to make that happen is that you were working together on certain things and trying to problem solve. Some of you got a little distracted and made it harder for me to help people. But what I wanted to mention was that the major thing I was doing with people is I was just reading these instructions. And I asked people, I was like, did you remove the parentheses using distribution? And if they hadn't, then what we would do is we would do that. We would find the number outside the parentheses, and we would distribute it in. And some of the things that I did to help was just to make sure that that process happened correctly. That if there's a 3 out here, you make sure you multiply by both things. Then I read the second one. And I almost like, most of the time I actually turned to the board and I pointed at it and I said, step 2, move all terms with variables to the one side of the equal sign. And a couple of your classmates helped me to realize that that word move is confusing.
Yeah.
Right. Can anybody explain why it's confusing? Like I probably shouldn't have even written that word. Why is that confusing, Opal?
Because to a lot of people, if you like take it and rewrite it on the other side, but it actually needs to subtract the opposite on both sides.
So I did a teacher fail. That's what I call this. I used wrong words that make it confusing. So, first off, I apologize. Second off, if the word move is confusing to you, please change it to add the opposite of all terms with variables from one side of the equal sign. So whatever you need to do to get in there in your brain, in your notes, to make it so that move means this, or you just get rid of the word move altogether. It's just gone. And you just think, hey, I've got this thing, and in order to get rid of it on this side, I have to do the opposite. And if you get more and more comfortable with that, these start to become systematic and almost boring.
Yeah.
Where you look at it and you just go, oh, I know I have to just add the opposite, get it over there. And then I get to this one and I'm like, oh, I know I just have to add the opposite of the constants. Get it over there. And the last step is maybe the most weird, because you go from adding opposites to, see if I can zoom in. Ooh, this is nice. Uploading the notes is actually better than projecting them. The last step is you have like 3x equals 15. It says once you have all variables on one side of the equal sign and constants on the other, divide by the coefficient of the variable. Can anybody put that in their own words? Divide by the coefficient of the variable. Rachel?
Is it the thing that you multiply by both numbers at first?
Ish. Yeah, so it's whatever you divide it or multiply by x to get that thing, you divide by it.
You divide by anything.
Yeah. Cool. That's if there was parentheses in the beginning, right? Yeah. Cool. So, the worksheet from the past 2 days has been challenging for some of us. It was probably 2 steps higher than the introduction concept. And so what I'm doing today is I'm going to try and find the middle ground with a middle step that takes away the parentheses. So all of the problems today have 0 parentheses. But what I want you to do, just make a choice. What I want you to do is to focus on showing your steps like I'm about to do. Okay. I want for your process to be almost computer-like. Super rigid, showing everything in just this very clear structure. So I'm going to switch to notes. I don't even want you to take these notes down. I just want for you, because I'm going to upload them, I just want for you to look at and engage your brain in what I'm doing. Okay? So, here is a problem that I am about to solve with/for you. Don't write it down unless you really want to, and if you find it helpful, that's cool. Most people, you don't have to write this down, but you do have to think about it. Okay. So, the problem that I want to go over with you is this one. And this is an example of how to document balancing equations. And this is the problem. 15 minus 4x is balanced, aka equal, with 2x minus 3. So I wrote it out very clear. I actually put some space there, and now I'm going to go through the steps that are in our note sheet. All right? And the first step reads, get rid of any parentheses or grouping by distribution. So I look here and I say, is there any distribution that needs to happen? No. All distribution is completed.
Should we write this?
Like I said, you don't have to. If you would find it helpful to document it, document it. No, she wasn't here the past 2 days. So then I read the second step, and it says, make sure that all of the variable terms are on the same side of the equal sign. So look in here. Is that true? Is it done? No. I've got x's on the left side and I've got x's on the right side. It doesn't matter which side you bring them. So I'm going to bring them to the right. And I'm going to bring them to right by what Opal said. Instead of saying moving, I'm going to say I'm going to add the opposite. So the opposite of negative 4x is positive 4x. So this is how I want you to document your balancing of equations. So on the second line, I wrote my action and what is happening on both sides of the equal sign. So I wrote it on the left side of the equal sign, and I wrote it on the right side. Does anybody else notice something that I strategically did in terms of placement? Try it? Yep. So I did a dashed line that was like, hey, this is my balance beam. Yep. Anything else that I did in terms of placement? Like, I put the 4x here, not here. And I put this 4x here, not there. Ella?
Under the like terms.
Yes, so I matched like terms. I'll get back to you. And so I matched the like terms. So this is like terms, and these are like terms. The reason why I did that is that these will cancel on the left side, negative 4x plus 4x, and 2x plus 4x gives me something new. Now all the x's, all the variables are on one side of the equal sign. So then, I've documented what I'm doing to both sides of the equal sign, and I show that something cancels. Next step is to write everything that's left. 15. What? Are you focused on what I'm doing or what somebody else is doing? Then I have to do this box, 2x plus 4x. I have to actually combine those like terms. Ella told us, or reminded us that they're like terms. 2x plus 4x is 6x minus 3. I just write the minus 3, just bring it down. Now that I'm here, you can ignore everything up here. Just completely ignore it because you've already done it. Have faith that you did it right. And then look at this line. This is the only line you care about. With this line, then, you read the third set of instructions on your note sheet, and it says make sure all the constants are on the other side of the equal sign. So I got all my variables to the right side of the equal sign. I want to get all my constants to the left side. Opposite of negative 3? Positive 3. So I'm going to add 3 to both sides. The whole point of doing the opposite was to cancel that 3, negative 3 on the right side. Then I'm going to add these like constant terms. And I will get 18 is equal to 6x. Yeah, so Ella went right to the last step, which is dividing by the coefficient. Divide one side by 6, divide the other side by 6, and the point is to have 6 divided by 6 changes into 1. And 18 divided by 6 turns into 3. So, this is, I call it sometimes the upside down pyramid method. Every step, your equation gets a little bit smaller because you're like compressing the like things together. You're getting all the variables together, you're getting all the constants together, and then you simplify the whole thing. You can always check your answer. I'm going to switch colors. 15 minus 4. And I'm just going to plug back in my value of 3 that I got and see if it works. So you check to see if your answer is correct. 15 minus, what's 4 times 3?
12.
Good. What's 2 times 3?
6.
Alright. What is 15? Oh, you guys see what I did? Sorry. I wrote everything else. So now 15 minus 12 is?
3.
What is 6 minus 3?
3.
That means we have a correct answer. I did a good thing. So that's how I want you to document your work today. Step by step, show what you're doing, both sides of the equal sign. Almost all the problems look exactly like this. Help each other out. Make sure you're adding opposites. This page has 2 sides. One has 12 questions. The other side has 10 with an answer bank that you can choose. These are the answers to these problems. And so this is your way of saying, hey, I got 17 and that's not in the answer bank. That means that I don't have a correct answer.
So do we just fit those with the problem?
Yeah, but I want you to actually solve it to make sure that it works. Okay. You can choose which side you work on. If you finish the 10 on one side, make sure you do the next 2 on the other side. We're going to have some more time. My goal is to come around and help you out. And see this.